Okay, this is proving identities. We will try to transform the left side of the equation to equate to the right side. So as for the first example, in this case, since sine squared is common, so we will just factor that one out. This becomes now sine squared theta plus cosine squared theta. Now, according to trigonometric identities, sine squared theta plus cosine squared theta, that is just equals to 1, correct? So you now have sine squared theta times 1, which is basically the same as sine squared theta. So we basically now have transformed the left side of the equation to equate to the right side. Let's move on to the second example. As for this one, okay, we will just break down tan into sine theta and cosine theta plus, and we'll also break down cotangent into cosine theta over sine theta. And then we will try to add the two fractions. The least common denominator is cosine theta sine theta. Again, according to trigonometric identity, sine squared theta plus cosine squared theta is just equals to 1 all over. Okay? And then what we will do is we will just try to break them apart into 1 over cosine and 1 over sine. According to trigonometric identities, the reciprocal of cosine is secant, and reciprocal of sine is cosecant. So as you can now see, we have transformed the left side to equate to the right side of the equation. Okay, moving on to our third and last example. So what we have here is secant squared theta multiplied by sine squared theta is equals to secant squared theta minus 1. Okay, so what I'm gonna do here is I'll transform secant squared theta into 1 over cosine squared theta. Multiply that by sine squared theta. So basically, I now have sine squared theta over cosine squared theta. And another way of expressing sine squared over cosine squared is tangent squared theta. Of which from here, using trigonometric identities, tangent squared theta is basically the same as sine secant squared theta minus 1, which we have now derived to have the same expression as the right side. That's now what you call trigonometric identities. That's all.